Right, so if you're anything like me, it's quite likely that your experience of tin cans are like this. This is the product you see on every market shelf. Now, it was invented in 1810 by a Frenchman following on from food preservation experiments in glass, and taken up in 1812 by the British, and by 1813 tinned goods were being supplied to the Royal Navy, and they included things like gunpowder and seeds and turpentine. And of course it's grown from then to be the most dominant way of preserving food and distributing it around the world, and there are some very good reasons for that. This has some very interesting properties. Anything in it, for instance, is immune from the light, it's immune from the atmosphere. Originally, they were made from steel coated in tin, which is where they get their name from, and they rolled these edges over and soldered them with lead-free solder. Of course, those things have changed. Nowadays, we don't use lead solder anymore for fear of lead poisoning, but there is a habit of coating the inside with plastic, and of course there's a worry about BPA leaking into the food, and so that's on its way back down as well. It is the most recycled product of anything that we produce, 65% of them being recycled. Now, they're not only recycled through industry, they get recycled at home. So these are used for things like cooking stoves, that sort of thing, and I'm sure you've seen those. They're used for pen holders and just a whole range of things where these get recycled. They're more recycled than aluminium cans, which account for about 55% of aluminium cans are recycled. But the way they're recycled is really quite impressive. The uses for them, how broad they are, is also quite impressive. Now, they don't come in a huge variety of sizes because it's a product of mechanisation. There's a great deal of standardisation. An awful lot of the world uses a standard size of 250, 500, 750 millilitres and 1 litre. The US based theirs on cup sizes, and we base ours on weight. It's a 250 gram, although because of density, of course, that changes. But they are regular sizes produced mechanistically in huge orders of magnitude. For example, there's a soup company producing a range of 11 soups who use 411 million cans every year. So these are produced in their billions, and you find them absolutely everywhere. Because when you take your food out, we don't do it really, we take it out and throw it away, but you're supposed to wash it. You take it out, wash it, you're left with an enormous stack of these things. And of course, having an enormous stack of these things immediately makes you think, well, what can you do with them? Well, as I say, most people are doing things like plant pot holders, pen holders, cooking stoves, that sort of thing. But I was introduced to a website recently, a YouTube site actually, where the chap was a Finnish artist in residence, and he'd been using some wind sculptures with various bits and pieces, and he did some experiments using tin cans, and I was pondering, could we replicate that en masse in a large scale to make something like the wind wall? Now, the wind wall is obviously something we've made before, and what it is a collection of small rotors that we can put across an area to form a kind of wind catcher. Wind catchers themselves have become quite interesting in wind generation per se. We're seeing the growth of wind turbines put in a square arrangement to form what is called the wind catcher, and that is reportedly more efficient than one single turbine and less costly. So this idea of the wind wall, which we've seen again before with an American artist who produced some conceptual drawings of what the wind wall would look like, to the model that we actually made. Now, if we put those wind wall ideas together along with this ubiquitous supply of material here, the question then becomes, can we make a wind wall out of tin cans? And why would you want to do such a thing? Well, it brings the idea of being able to make a wind generator machine that could be installed absolutely anywhere, that is within anybody's capability, and the raw materials to make it are readily available. What more could you actually want as a wind generation scheme that could be put into practice requiring only one thing, and that is the willpower of the people to do it? So what I thought I'd do was look at turning this into a wind wall. Now, clearly I've got 4 cans here, so we're going to make a demonstration model of 1, but the idea would be to put a whole stack of them together again to make that wind wall device. Of course, there are lots of different ways that we can look at solving a problem like this. One might be to make a erroneous type, another would be to use this as our inspiration. This is a rotator out of an upright fan, and we've done lots of things before where we've shown that this actually makes a really good rotor, both for wind and for water. But the key to it is replication of lots of little bits of trash to make units that we can put together, to put those together into bigger units to make our generator. So that could be done just by slotting down here. Of course, we could do the Savonius type as well, where we just put 2 slots in. There are lots of ways of approaching it. So what we're going to do is a 3-bladed design. Now to do that we need to mark it out. So here's my can. You'll notice incidentally I've drilled a hole in the bottom of the can. That's so I can put the axle through later. Draw a circle on a piece of paper and mark out 120 degrees, because each 120 degrees is going to give you where these blades are going to be. So you mark 120 degrees onto your can that you've put onto your piece of paper. Then 30 degrees off you put another mark. That mark you transfer onto your can. Flip it round, make sure the 120 degrees are in line, because they're going to the main part of your bend, and then mark those again, and then mark the black marks. And what you'll get is this. We've got a green mark here and here, which are going to be the straight line, and then at the bottom of the can, anti-clockwise, we've got a black mark, which is the 30-degree mark. And because we flipped up the can, and then here at this part, we've got another mark, which is the same mark, but this time it goes clockwise. So we've got a clockwise and anti-clockwise mark to each of the 3 central marks that we made. And what we want to do is join those up. Now we don't join them up that way, crossing the green marks. You join them up that way so that the green marks are uncrossed. So we join those like that. And that will make our 3 blades, where we twist them around the green mark once we cut them out. So now we need to cut them out. Cut them out with a Dremel and you'll get this. They'll spring out a little bit. And you can see we've got a slanted blade, and the green marks there are the bit that we twist. So we can twist those around and twist, and we get this. And we need to make 4 of those. And there it is glued together. Now to finish the rotor we need a couple of plastic discs that I cut out with the hole saw, and then I sanded them down until they fit in the top of the can. And obviously I've got another one the same size which fits on the bottom of the can. Bit of aluminium bar makes my axle, and I can shove that through. And now it is completed. Now put it into a cradle just so we can see it spin, and I'm going to turn a hairdryer on it. Hairdryers don't blow a huge amount. That really is quite cool. Obviously I've got it laying down, but in a wind wall it would be that way up. We'd have a whole load of them, and we can build those up to whatever size we want. So there is a really cheap way of making a wind turbine or a wind wall that's pretty much within the reach of anybody. She finished the wind wall, at least the wind wall prototype, and it got a great response, and with some really good suggestions on how to improve it. And of course I'm going to pick some of those suggestions up in the following few days. However, there was one really good one that I liked immediately, and that was by James Conliff. Now, he suggested an easier way of making those columns, because what I did was chop up guttering and stack the guttering up. Now, it wasn't difficult, but it was a little bit more time consuming than maybe it should be. And what James suggested was doing one single column out of a piece of pipe, and that's what I've got here. I've got a bit of soil pipe, so this is 110 diameter. And what he said was, slice it down and twist them out as blades. You'll change it from a drag type to a lift type, and you've only got 3 cuts to make. It should be easier, shouldn't it? And I thought, what an awesome idea. So I'm not 100% sure I've got it right what James was saying, but this is my interpretation of what James was going to say. So I've marked up this piece of pipe at 120 degrees, and I'm going to put a cut line down the 120 degrees, and then 3 centimetres up, put a cut line across, heat that joint and twist the joint out to make fixed blades. Now to cut this stuff, I find it easier to use an angle grinder. So having done that, what we've got is a little tongue right there, because I've sliced up here as well. And what we need to do is put a heat gun on that and then give these a twist out to about 36 degrees. And when you've done that, this is what you get. It was actually surprisingly easy, and it's really quite sturdy. The PVC holds the heat for a little bit, so you heat one side, heat the other, and you can bend that, hold it into shape until it resets again, and then you've got this really rigid shape. Now, I'm loving this actually. I'm going to call it the conliff rotor. Anyway, we need to put a bar down there to make it rotate centrally, of course. And what I tend to do is cut a couple of discs with a hole saw, because we know they're centered. So a couple of discs with a hole saw, glue them in the ends there, and then we can put an axle down there and it will rotate between those two centers. And that's the rotor finished. Now I'm just going to knock up a quick U-cradle and we'll take it in the wind and see what it does. Okay, I've bunged it in a quick cradle. Yesterday we had a blustery day, and today we're getting nothing at all. So I'm going to simulate the wind with this air blower. And, you know, an air blower is a bit equivocal, isn't it? But we should be able to get this thing spinning at about 1 metre a second or something like that. And there you go. Pretty awesome, actually. So thank you very much, James, for that suggestion. Now, it is quite stiff, but obviously in high winds, there's maybe flex in this blade. So what you might want to do, actually, is just cut it halfway and leave a central disc to stiffen the blade up. So you would just cut it to there, leave a disc, cut it to there, and do the same heat treatment to bend it out. Now, I did try this 2 ways. One way I tried it was where this notch was in the centre, and when I twisted it round, everyone met at the centre. That's much more like a Savonius type. The other way is I cut the notch towards the back and we twisted it out and we got more of a blade, so this will be an airfoil lift type. Now I did 3 because the game suggested 3, but I think it was me when I do this again I'd do 6. So cut it into 6 pieces, leave the notch at the end, bend it out, and then you'll get actually quite a good rotor. And it was certainly really easy to make. I mean, all I did was chop it, put in the 3 lines, apply a heat gun, piece of cake to make. So I really liked it. Thank you very much for that suggestion, James. It is called the conliff rotor, and I think it's an awesome idea if you're thinking about a wind wall. You don't fancy Savonius type blades and you'd much prefer a blade system like this, then I think it'll work just as well. I mean, we do have to load it up and all that sort of stuff, obviously, and you know, if you nail a cat to a stick and put it in front of a blower, it'll spin. So it spins beautifully and it has real potential. The real plus point of it was so easy to make. We 3D printed this, which is the Ogrensky wind turbine. Loved the idea of it, 3D printed it, and all I've done, stack them up and glue them and stick this rod through. This is a bit of 8mm rod, and then you'll see there's a tube there at 10mm, and I've done that because the bearings we're going to use are these things, which are skater bearings, and they're 8mm centre. So we can put a couple of bearings on there, and we've got ourselves a wind turbine. Now, I did need the 3D printer to make this, and I think that making it by hand is going to be a little bit challenging, which is why I used the 3D printer. But we did do a version of this using a Savonius wind turbine, where it's basically a couple of bits of gutter, cut it to section and glued on some discs like that, and that's how we made the wind wall. But this is supposed to be much more efficient. I can't say anything about that. I don't know. I haven't tried it, but it's supposed to be. One thing it certainly is hugely sexy. So I need to make a case for this to go into, and I'm going to make that case, and regular viewers of the channel will know exactly what I'm going to make it from, and that's this stuff. Now, I call this stuff builder's board. It's actually UPVC board with a foam core that's used in Europe and Britain all of the time. It's a building product, so it's meant to take some pretty heavy-duty battering by the wind, and it's meant to last about 25 years or so. The joy of it is it comes in a massive amount of sizes and thicknesses, right the way down from 25mm up to, I think, 300mm. It glues with this stuff, crazy glue, and the glue bond is actually stronger than the material. It's round about, maybe a little bit more expensive, actually perhaps not these days, it's round about the price of wood, and it cuts with anything, a circular saw, a chop saw, a hand saw, a hacksaw, carpet knife. It's just so easy to cut and use and glue together that it makes structures really quickly, particularly when you're thinking about stuff and prototyping stuff, but it's such a heavy duty thing, your prototype works out, then you can just leave it there because you've got 25 years on the thing. Pretty cool. Anyway, from the previous video, when we put this, we got a couple of comments from people worried about birds. I mean, the problem with HAWT wind turbines, the big old 3-bladed things, is the bird's flying along, you can see the blade, then he sees this great big gap and thinks, oh yeah, I can go through that. Goes through the gap, and of course by that time the blades come around and it chops it into little pieces. This thing, it's a solid column, okay? So the bird's going to come along, look at that column, and of course it rotating doesn't go outside of the column. He's going to think, oh, there's a big column. And of course some birds do just fly into buildings, but then Darwin Award prevail. So this is less likely to chop birds to pieces than a HAWT, I would have thought. However, if you're unhappy with that, I suppose you could always put razor blades around here and make it a real bird mincer. But this is gonna be safer. And the other thing on birds, interestingly enough, because somebody did post something to me, I had a look at the research on it, and there is research on the number of bird deaths in horizontal wind turbines. Turns out, quite a lot of those are commissioned by Big Oil, which I thought was hilarious. But it is a serious worry. Birds do die in these things. It's 0.016% of the bird population of the US has died in wind turbine accidents. And so it is an issue, hey? But I would think that this thing, being a solid that the bird can see, is going to be far less damaging than a HAWT, where the bird just can't see the blade coming. And remember, at the tip of these blades, they're supersonic speeds. So basically, a bird doesn't stand a chance. Here, it doesn't extend out beyond it. It's a nice solid column. I would have thought it would be an awful lot safer than HAWT. Anyway, what we're going to do is cut that framework out of the builder's board. Oh, incidentally, you can get this board in the US. It's called Sintra board, S-I-N-T-R-A. I believe it's quite expensive, in which case you're going to be using wood. Here, like I said, we're going to be using this because it's really cheap and easy to work with. So let's cut some of that up, make a frame for that. Okay, that's it. Now, I haven't bothered to show construction details because it's just a plastic box. I cut them to size, glued it together with super glue. I've put these on just to stiffen it up a bit. In the real version, these little wings wouldn't be there. So they wouldn't have these attachments on. It'd just be box after box after box for the length that you want. This thing here is the generator. It's actually a motor that I got from an AC unit. It's a brushless DC motor. Now all we really need to do is get some wind on it. Yes! Well, that was awesome. Oh man. 3.7. When it gets to 3.7, it lights that up. That's about 25 volts.
That is awesome.
It's awesome. Yeah, 3.8 and it lights up.
Look at it go.
Yeah. Shame it's blustery.
Yeah.
Okay, so that was awesome. I'm not schlepping our meters out there because you could see it was raining and meters and rain do not do well. But we got the thing to light, and this thing has a turn-on voltage of around about 20-25 volts, something like that. And it's pretty bright, so we're probably looking at sort of a 25-30 volts. Now, the amount of power you get out of these things actually depends on this bit. It's what the diameter is and what the height of that is and what the wind speed is gives you the amount of energy you can expect to harvest from something. And for this size and that wind speed, it's around about 500 milliwatts or so. It's got nothing to do with this. It's all to do with this. We want more energy, we need more wind speed, or a bigger or more of them, and we'll get more energy. what happens is the efficiency of this turns that energy into electrical energy. Now we were probably getting somewhere around about, I don't know, 300-400 milliwatts out of it, something like that. So that's actually pretty cool for what that was. So it is performing in the region of what you would expect it to perform. Now, it was a bit of a pain to make this Ogrinsky style turbine, because I think that the only way of doing it is to 3D print it. But the performance is pretty good. I was quite impressed by that. If we get some wind and no rain, I'll drag it back out and we'll get some meter readings. But right now, it's looking very promising. Anyway, I hope you enjoyed the video. And remember, the idea of this is a wind wall. We have a bank of them, not just the one. And this is only 50 centimeters tall, so it's half a meter. We really want it about meter, 1.2 meters, something like that. But, brilliant. Thank you very much for watching. Please do remember to like and subscribe.